All right, this video is to go along with lesson 10.2, find arc measures. So first we're going to quickly go over the vocab and then postulate and then a couple examples. This one will be fairly short. Okay, so first, an arc is it's a portion of a circle's circumference that is sectioned by a central angle. A central angle is just some angle formed between two radii, like theta here is the central angle. The length of an arc is actually exactly equal to the measure of the central angle. And we can actually write that. So, for example, maybe if I said that theta here was equal to, I don't know, 65 degrees, the length of this arc right here, measure of arc AB, is equal to 65 degrees. There are a couple types of arcs. The minor arc is the arc that is less than 180 degrees. Actually, I should add something here as well, but you guys know this one anyways. A arc that is exactly 180 degrees is a semicircle. 180 degree arc. A minor arc is the smaller of the two points on the circumference, the smaller arc formed by those 2 points, and the major arc is the other way around, an arc that is more than 180 degrees. Now, with a major arc, you are going to need a third point somewhere on the major arc that you'll go through to get from the starting point A to the ending point B. So we're going to use a 3-letter naming convention for major arcs versus minor arcs where we'll just see 2 letters. So if there's no, if you only see 2 letters, assume it's a minor arc. The major arc, the longer way around to get from A to B, will typically have the 3-letter naming. All right, so it's a little vocabs for arcs. Now, please note, because the measure of an arc is equal to the central angle, the sum of all arcs will add up to 360 degrees if we added all of the arcs, which brings us to the arc addition postulate. Very much like the segment addition postulate or the angle addition postulate, which basically says the big thing is made up of the sum of the 2 small things. We actually have the exact same thing here for arcs. The measure of arc ABC, which starts at A, goes to C through point B, that is equal exactly to the measure of arc AB plus the measure of arc BC. All right, so that's the vocab and the property that we're going to need for the practice problems from 10.2. Quick little example here. Zoom in a little bit here. Okay, so in this example here, I give a central angle measures. I call this center, let me call that D, I guess. The measure of angle ADB is equal to 120 degrees, and the measure of angle BDC is 135 degrees. All right, we can figure out all of these arc lengths. Now, the first thing, we can actually get this central angle ADC by taking 360 degrees and subtracting the two central angles we know, which I think that's 105. Let me just double check here. My mental math is definitely not firing on all cylinders lately. Yeah, 105. That should have been obvious. And then we'll just add that info right into our picture. You know, once you realize something, mark your picture up. Always fun. All right, let's take a look at these 5 examples real quick now that I figured out that other central angle. Measure of arc ABC. So we're going to start at A, we're going to end at C, and we're going to go through point B to get there. So starting at A through B, stopping at C, we're going to add these two together. So that is going to be 255 degrees. The measure of arc ACB. Now we're starting at A, going through C, and stopping at B. So we're looking at this portion. So we'll add those two central angles together, and that is going to be 240 degrees by just adding. I should remind you what I'm adding together here. That's a plus. And again, I added the 105 degree plus the 135 degree to get 240. Okay, the measure of arc AC, we actually kind of already figured that out a moment ago. That's just going from A to C. And again, with the 2-letter name, we're going to consider the minor arc with the 2 letters. The major arc, I'd give some 3rd letter in the middle that I have to go through to get to the end point. So it's just going to be plain old 105 degrees. And lastly, measure of arc BCA. So we're going to start at B, go through C, and stop at A. And evidently we already answered that question because measure of arc BCA and measure of arc ACB is actually the exact same thing. But that's okay. That's another important convention to know. Just like angles, the 2 terminal points or the end points can be the 1st or 3rd letters as long as the point in the middle is in the middle. So arc ACB and arc BCA are actually the exact same arc. All right, that is 10-2.